Right now, 93 million miles away, a reaction is happening that's been running non-stop for 4.6 billion years. No batteries, no fuel tanks, no off switch. Every second, the sun converts 600 million tons of hydrogen into helium. The energy released? Enough to power human civilization for 500,000 years. And we're about to steal it. For decades, scientists said it was impossible, too hot, too unstable, too far away. They were wrong. Welcome to Episode 1, Stealing Fire from the Stars. Here's the insane part. The fuel is everywhere. Picture this. Fill a bathtub with seawater. That bathtub contains enough deuterium to match 300 liters of gasoline, enough to power a car for 3,000 kilometers from one bathtub. The other fuel? Lithium. The same stuff in your phone battery. There's enough in Earth's crust to power humanity for millions of years. No carbon emissions, no meltdowns, no radioactive waste lasting millennia. Just clean, limitless energy from the reaction that powers every star. Sound too good to be true? It is, because there's one problem. Stars don't work on Earth. To understand why fusion is so hard, you need Einstein's 1905 breakthrough. E equals mc squared. Mass and energy are the same thing. Convert a tiny bit of mass, get massive energy. How tiny? 1 gram of matter, a paperclip, releases 90 trillion joules. That's 21,000 tons of TNT. The Hiroshima bomb? 15,000 tons of TNT. 1 paperclip contains more energy than that bomb. In the sun, fusion unlocks this energy. 2 hydrogen nuclei slam together, form helium, and a tiny bit of mass disappears, becoming energy. But there's a catch. Nuclei are positively charged. They repel like magnets pushing apart. The sun overcomes this with brute force. Pressure 265 billion times Earth's atmosphere, combined with 15 million degree temperatures. On Earth, we can't recreate that pressure, so we cheat. We use higher temperatures. 100 to 150 million degrees, 10 times hotter than the sun's core. At these temperatures, matter becomes plasma. Electrons ripped from atoms, creating charged particles moving fast enough to overcome repulsion and fuse. Which brings us to the question that's haunted scientists for 70 years. How do you hold something 10 times hotter than the sun? You can't use a container. Plasma vaporizes any material instantly. So we build invisible cages made of magnetic force. The Tokamak, a massive donut 10 meters across, uses magnetic fields so powerful they could lift a tank to suspend plasma in midair. These fields come from superconducting magnets cooled to nearly absolute zero, creating a cage millions of times stronger than Earth's magnetic field. ITER, in France, will be as tall as a 7-story building. China's EAST and South Korea's K-Star are perfecting this approach. There's also the Stellarator. Imagine twisting a donut into a pretzel. Germany's Wendelstein 7X took 19 years to build because its geometry is so complex. This is completely different. Instead of holding plasma for minutes, we compress fuel so fast, fusion happens in billionths of a second. The US National Ignition Facility uses 192 laser beams on a fuel pellet the size of a peppercorn, delivering energy in 20 nanoseconds, creating pressures 100 billion times Earth's atmosphere. The Mariana Trench have 1,000 times atmospheric pressure than normal. NIF creates pressures 100 million times greater. In December 2022, they achieved ignition, more energy out than delivered to the fuel. For the first time in history, they crossed the threshold, and there's no going back. Let's put this in perspective. A single fusion power plant could generate 500 megawatts, enough for a city of 500,000 people. Annual fuel needed? 250 kilograms, the weight of 3 adults. A coal plant producing the same power needs 1.5 million tons of coal per year, 6,000 times more fuel, releasing 3 million tons of CO2. Fusion? 0 emissions. Nothing. If we crack fusion at scale, we're not just solving the energy crisis, we're rewriting civilization's economics. Energy becomes abundant. Desalination becomes cheap. Carbon capture becomes feasible. Vertical farming, synthetic fuels, hydrogen production. Technologies that use too much energy today become practical. For 70 years, fusion has been 30 years away. But something's different now. The timeline is accelerating. Records are falling. Billions are pouring in. The question isn't, can we do this? The question is, how long until we do this? In episode 2, we'll show you what changed and why the next 10 years will determine if humanity gets unlimited clean energy or if we keep fighting over fossil fuel. This is just the beginning. The power of stars is coming to Earth.